right, you guys have your calculator? We are going to find the cosine of 28 degrees. But it says 28 degrees, so you have to be in degree mode. So we're going to go to our calculator and we're going to check to see that we are in degree mode. Second mode. Just kidding, just mode. And then mine says radian or degree, and I have degree highlighted right there. So you need to have degree on. Lindsay, if you're not sure, we'll find out what you have when you type in what we do, okay? And then to get out of it, then you can hit second mode, and that is your quit. So for the first question, we're going to literally type in cosine 28, and it knows it's degrees because we just put it in degree mode. Enter. In the directions, it says to round to 4 decimal places. So we're going to look at that 4 and round, just keep it at 9, 0.8829. And that is the cosine of 28 degrees. Second one, tangent. 34 degrees, 12 minutes, 51 seconds. We're going to go to our calculator. We're going to type in tangent. And then it's 34 degrees. Remember, to get degrees, we do second angle 1. And then what are my minutes? 12 minutes. So we do second angle minutes. And our seconds, 51. And remember, the seconds are alpha plus sign. Enter. And we get our tangent. We're going to have to round this to 4 decimal places. So look at the 5th decimal place. That's a 6. That tells us to round the 9 to a 10. If it's 10, then I got to carry the 1, which rounds that 9 to another 10, which I have to carry the 1. So I'm going to get 0.6800. Approximation. All right, next question. Cosecant 12.6 degrees. Yes, Carla?
How do you put the sentence to the calculator?
Alpha, and then plus sign. Okay. The third one is cosecant, and there is not a cosecant button. So we have to know, what is cosecant the reciprocal of? Sine. So we're going to do 1 divided by sine 12.6. So that's what you'll type in your calculator. 1 divided by sine 12.6. Oop, I typed too many 6s. 1 divided by. Approximately 4.5841. And the last question, cotangent 19 degrees, 16 minutes, 26 seconds. Can you do that one while I work it out? If you haven't. So 26. I like the go-to when I accidentally type something in wrong. There we go. 2.8597. Okay. Next section. All right, this says find the value of theta in degrees and radians without a calculator. So don't touch your calculator. We are going to find the degrees first. So here's a hint. All of these are special right triangles. They're either the 45, 45, 90 degree triangle or the 30, 60, 90 degree triangle. So I could, if I need to still, if I don't have them memorized yet, I can go ahead and draw those triangles. So we've got our 30, 60, 90, and we've got our 45, 45, 90. You do need to know, in a 30, 60, 90, the 30 degrees is the smallest angle. So across from the 30 degrees is always the smallest side. What is the measurement of that side, or the ratio measurement? 1. And then we go to the hypotenuse next. 2. And then we go to the third side. Square root of 3. There's 3 sides, they're all different. That one's going to be the square root of 3. For the 45, 45, 90, we've got 2 sides that are exactly the same. They're the smallest side. 1. Hypotenuse, square root of 2. There's only 2 different sides on this one. So we're going to look at the sine of theta is equal to square root of 2 over 2. So this is saying we need to find theta. We need to find which degrees is the sine, square root of 2 over 2. Remember, the sine is opposite over hypotenuse. I don't really even have to think that much. There's only one triangle that has square root of 2. So what's the degrees? It's got to be 45 degrees. You can't use the 90. Yes? Oh yeah, I changed them. So do these. You'll find out. Well, maybe you won't realize it later, but there was a reason why I did change them. Sorry about that, I forgot to tell you. Okay, so we have 45 degrees, and then we have to convert that to radians. And we have learned a way to convert it to radians, but I'm not going to do it that way. But we have learned a way to convert it to radians. What's our way to convert to radians? You multiply by pi over 180. Right, but this is without a calculator. So I don't want to have to do something so challenging without a calculator. So instead, I'm going to think about where 45 degrees is on the unit circle, but just the top half. The top half, 180 degrees, is what in radians? That's pi. And how many times does 45 fit into 90? Into 90, 45 fits in 2 times, exactly. So it fits into 180 4 times exactly. So 45 is what fraction of that top? A 4th. So it is the pi divided by 4, that is the radians. It's the top pi and divided by 4. That's 45 degrees. So question B, the degrees. Cosine theta is square root of 3 over 2. Which triangles that definitely have to be in? 30, 60, 90. So we're going to figure out which angle is the cosine, the adjacent square root of 3. Is that 30 or is that 60? Adjacent, 30. This is the adjacent. So we're going to be using 30 degrees. And for the radians, we're going to do it this way again. We're taking pi, and we're fitting all the 30s, as many 30s in as I can. How many 30s fit into that 180 degrees?
6.
Yeah, 6. So one of them is pi over 6. One of them is pi divided by 6. The next question is tangent of theta is 1. Tangent of theta is 1. Remember, tangent is opposite over adjacent. So for it to be opposite over adjacent and equal 1, it's the same number. Which one's got 2 of the same side? 45 degrees is the answer. And what is that as a radian? Already did it. Pi over 4. Question D, cotangent of theta equals square root of 3 over 3. So I see a square root of 3. I know it's got to be the 30, 60, 90. But I'm not really familiar with cotangent as much as I am with like tangent. So I might switch it. And this might still not help you, because what happened was there was some rationalization that they had done. So I'm going to rationalize this one. I'm going to get 3 square root of 3 over 3, which reduces to just square root of 3 over 1. And remember, tangent is opposite over adjacent. So which angle is opposite the square root of 3? 60 degrees. And then we're going to convert that to radians. Here's pi. How many 60s fit into 180 degrees? 3 of them. So one of them is pi over 3. If you have questions, stop me. You can answer every question. Yeah, sorry. Notice the next section says grab your calculator. All right, next section, we're going to find the value of theta in degrees, but we're going to do this using the calculator. So to find theta, what we're really doing is we're going to be solving an equation. We're solving this equation where we isolate theta. We're going to get theta by itself. So what do I have to get rid of so I have theta by itself? Cosine. The only way to get rid of anything is to do the inverse operation. So if it was being added, I would subtract it. If it was being multiplied, I would divide it. Cosine has an inverse operation. It looks like this. Cosine inverse. And if I do it to one side of the equation, I have to do it to the other side also. So that cancels out the cosine. And we get left over theta equals the cosine inverse 0.9370. So what I type into my calculator is that cosine inverse. To get that, you do second cosine, 0.9370. Do you notice I changed these two? Okay. Second cosine, what was it, 9.370. So it is approximately 20.454463. I don't know how many decimals you feel like doing. I'm going to do 2. 20.45 degrees. And then we need to find this answer in radians also. How can we convert from degrees to radians? What do we do to convert degrees to radians? Multiply by pi radians over 180 degrees. So after I got this answer on my calculator, I'm just going to hit times pi divided by 180. So I just left that answer and I hit times pi divided by 180. So it's using my last answer. I didn't have to round anything. 0.36 radians. So the next one, to cancel out cosine, we're going to use the inverse. And we're going to apply that to 0.7771. And you're doing this on your calculator. And then afterwards, I'm going to multiply it by pi, divide by 180, and I get my radians. So my degrees, approximately 39 degrees, and my radians, approximately 0.68. Okay, so the last section is we're going to find the value of x, and all of these are special right triangles. So if you know your formulas, you can use that to solve for the x value. 45, 45, 90. We know our reduced ratios would be like 1, 1, and square root 2. And to get from the side length to the hypotenuse, what do you do to this value to make it into the hypotenuse? How do I get from 1 to square root 2? Yeah, you're taking the leg and you're going to multiply it by radical 2. So if the leg is 5, then what's our x value? Radical 2. Number 2, we've got 30, 60, 90. Across from 30 is always 1. Hypotenuse is always 2. Then the third side is square root 3. We have to find the hypotenuse. It's double the short side. So x is times by 2. What do we get? 16. Good. Number 3, 45, 45, 90. So we're going to start with 101, and this is really like 1 square root 2. So we're taking the leg and multiplying it by square root 2. So 12 square root 2 inches. Then we've got 30, 60, 90. 1, 2, square root 3. We're going to take the short leg multiply it by 2 to get the hypotenuse. So our hypotenuse is 24. What times 2 is 24? Easiest math we've done all year, right? Nah, that linear velocity stuff is cake. No? Okay. Number 5, we've got a 1 square root 2. So we take the leg, multiply by square root 2, that equals 12. So how do I find the leg? How do I find the leg? Divide by square root 2. X is 12 divided by square root 2. Only, nope, it's not. What do we do to it? Multiply by square root of 2 over square root of 2, a value of 1. Go straight across, we get 12 square root 2 over 2. Still not the answer. Right, 6 square root 2. And then the last question, we've got 1, 2, square root 3. We take the short side, multiply it by square root 3 to get the longer leg, the medium side. Also, the short side times 2 is the hypotenuse. So we're going to need that hypotenuse to find the short side and use the short side to find the medium side. So what's our short side? Okay? 9. We take 9 and we multiply that by square root of 3. And that's our medium side.
How do you know the short side times radical 3 is medium side? All that stuff.
Previous course, geometry or algebra 2 last year. You should have learned it. That's how we know. So we're just reviewing what you. So if you don't know it, now you gotta learn it.
Is it supposed to be like memorized, or
Yeah.
can we figure it out from the triangle?
Let me pause it for a second.